Here is another image of the aqueduct, and you can see the higher land where the water source is, and then as the land slopes down on the other side of the river, the aqueduct system continues down into the city of Nimes. We're going to be looking at this as a feat of engineering and also to understand some more architectural concepts, or I should say structural concepts, techniques, technology for building, because we're going to be looking at a lot more structures throughout the Roman Empire. And this is a good example of, or a good way to start our understanding of Roman architecture. We see 3 levels, and the water would be carried in a channel on that upper level here. There you go. Originally, the entire upper channel would have been covered, and again, because the Romans are so efficient, they covered it to prevent evaporation and any debris from falling into the clean water source. Now, these images also show people on top and inside. I don't know if you can still do that today. The Pont du Gard is part of a national park, and you can visit. It has a visiting center and hours and buy tickets, but I'm not sure how much of the Pont du Gard you can actually walk and explore now. These are older photographs, but they do help give us a sense of size and scale. So the channel itself is over 6 feet deep, and that water would be rushing through this and covered to prevent evaporation and any debris from falling in. The channel of water right here is maintained at a slope of, well, a slope of 1 degree. What are you talking about, Miss Cortez? What is this, a math class? Hang with me here. Rather than using a complicated system of pumps to push the water from the source down to the city of Nimes, that's not efficient. The Romans are all about efficiency. They simply put it at a low slope and let gravity push the water down into Nimes. The length from one side of the Pont du Gard to the other has only a 1 degree difference in height. Those 2 rows of round arches beneath the channel are there to maintain this slope throughout a rough, or I should say a varied landscape. Isn't that insane? It is a feat of architectural genius. So we have a channel of water which is at a 1 degree slope, just enough for gravity to push the water from the source down to Nimes, and then those archways are simply there to maintain this as the terrain goes up and down and around. Crazy, right? Let's look at why they chose these rounded arches and not a post and lintel. Why not put some pretty columns there? Why are you doing these rounded arches? These rounded arches, which we can call more specifically a row of arches, is called an arcade. These arches, or these arcades, are more efficient than post and lintel construction. We know that with posts and lintels, the lintel can only carry so much weight before it cracks. That tension will break and the whole thing will collapse. With a rounded arch, which is what we have here in the Pont du Gard, we have an efficient distribution of weight. Here, to help you, I have this diagram. So the force of gravity pushing down is directed to the posts, which can handle the weight much better than the center of the archway. So what we have is efficiency. The force of gravity is being directly put onto the posts, and the weight is being lifted from the center. This rounded arch makes this Pont du Gard possible because of the intense weight of the water and of maintaining that terrain. You're going to need something much more efficient than rows of columns and all these little lintels. That's not efficient use of stone or labor or time. Got it? The structure itself is carved out of stone, and the stones are placed together and locked by a keystone. So this diagram here is showing you how these arches are created using stone blocks. You have these stone blocks in these V-shaped wedges called voussoirs, and you lock the voussoir in place with a center stone. I say lock in place because that's literally what it's doing. You have your voussoirs and they can fall, but when you add that center stone, it wedges in and locks everything in place. That locking gives it the name keystone. Keystone. Get it? Key, lock. So the keystone is at the center, and that force of gravity on the keystone wedges it in place and holds all of those voussoirs in place as well. And that's the system of construction used to make this rounded arch. Now, in architecture, architects, they love to name everything. So let's look at that. The keystone is here in the center. The open area under a rounded arch is called a bay. And the space between arches are called spandrels. All right? So a bay is the space under an arch. Spandrels are the spans of wall between two arches. Now, another thing about the Pont du Gard. Let me just ask you, what are these things here? What are these blobs, these blocks sticking out the side? Portions of the Pont du Gard were restored, rebuilt in the 19th century, but those blocks here, those are from the original Pont du Gard of the Roman times. What? The construction crew was tired and they didn't want to knock off those edges? No. Think again about efficiency. The Romans are all about efficiency. What do you think those would have been used for? They go up on all the sides of the Pont du Gard. I heard you. You said it, didn't you? Scaffolding, ladders, climbing. Yes. So these outcrops of rock, these blocks that stick out from the side, those are meant to help you in maintaining this aqueduct, because things are going to happen. Things are going to get clogged up. Maybe there's a dead deer that's clogged up the water up there. Rocks are going to need to be replaced. Bricks are going to need to be replaced. So instead of having to build up a scaffold and ladders every time, if you just leave some of these blocks out, you can put some you can put some boards up there, climb up there, and then boom, you got your scaffolding. Now you can go in and start making repairs. So it's about efficiency rather than aesthetics. It's not there to look pretty, it's there to maintain a very vital source of water for the city of Nimes. Those Romans and efficiency.